Hello student, today we are going to start a new chapter, that is a matrices. In matrices, we should know the definition of matrix. So it is the definition of matrix. Without fail you remember this one. Also you remember some examples how to denote by matrix, that is by capital letters, and elements by small letters. Also determinant of matrix, non-singular matrix, minor of an element, cofactor of an element, adjoint of a matrix. Also you should know how to find A inverse by adjoint method, that is the A inverse equal to 1 upon determinant of A into adjoint of A. Also you should know elementary transformation, in that row elementary transformation as well as column elementary transformation. So these are the elementary transformations. Also remember here equivalence matrix and inverse of a matrix. There are different methods to find the inverse of matrix. For example, adjoint method. Also the inverse of matrix by using elementary transformation. Also Gauss-Jordan method. So you have to use any one from this. Before to start the rank of matrix, this is very important topic now. But before to start the rank of matrix, we should know the basic definition and different types of matrices also. Just like a row matrix, column matrix, square matrix, rectangular matrix, upper triangular matrix, lower triangular matrix, determinant of matrix, symmetric matrix. And now start the very important topic, that is the rank of matrix. So what is the rank of matrix? So here is the definition. The matrix A is said to be of rank R if at least one minor of order R is non-vanishing. Non-vanishing means non-zero. And second, every minors of order R plus 1 vanishes. Vanishes means equal to 0. It means that a matrix is said to be of rank R if it satisfies these two conditions. In short, we can say rank of matrix A is highest order non-vanishing minor, and it is denoted by row of A. So here is the notation, a row of A. You must note, if the order of matrix A is m by n, then rank of A is less than or equal to minimum of mn. So here is one example you can take. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the order of this matrix? It is nothing but 3 by 4. And here rank of matrix A is highest order non-vanishing minor, means minor we have to find. So in this case minor means determinant. So here order is 3 by 4. So for example here a minor means determinant of order 2. This is. Also one can consider 2, 6, 3, 7. This is a minor or determinant of order 2. If I want to consider 3 by 3 means determinant of order 3. So this is a 3 by 3. One may consider different like this one. So 3 by 3. So it's a determinant of order 3. So what is the highest order determinant there we can consider in this matrix? So highest order determinant is 3. Or you can say 3 by 3. So what is the rank? Rank is highest order non-vanishing minor, means possible highest order determinant is 3. It means that it is a minimum of this one. So that is why rank of A always less than or equal to minimum of m and n. In this case rank may be 3, 2 or 1. Second thing, if there exists a non-vanishing minor of order R, then rank of A is greater than or equal to R. It is very clear from the definition itself. non-vanishing minor of order R. So definitely highest order non-vanishing minor is greater than this R, means rank of A is greater than or equal to R. Note that these notes are very important. It directly related to your exam. When we are solving the examples or MCQs, that time we require these notes. So without fail, you just go through all these notes. If all minors of order R plus 1 are 0, then rank of A is less than or equal to R. Again the same thing by definition. Next is the elementary transformation does not alter rank of matrix. Next, the rank of product of two matrices is not exceed the rank of either matrix. It means that rank of A into B is always less than or equal to rank of A, and rank of A into B is always less than or equal to rank of B, means both. Rank of null matrix is 0. It is very clear, then rank of non-null matrix is greater than or equal to 1. If A is a non-singular matrix, means what? It is a square matrix, first thing, and determinant is not equal to 0, means highest order determinant is order itself. It means that if A is a non-singular matrix of order n, then rank equal to n. And if determinant of that square matrix of order n equal to 0, means highest order determinant or minor is equal to which vanishes, means definitely rank is less than n. Rank of identity matrix means unit matrix is equal to order of that matrix. Why? Because unit matrix is non-singular matrix, and determinant of unit matrix is always 1. It means that the rank of identity or unit matrix is equal to order of matrix. What is next? The rank of matrix A and its transpose is same. Next, the rank of matrix A and A inverse, if exists, is same. Now the echelon or canonical form of a matrix. So first, the definition of echelon or canonical form is the echelon or canonical form of matrix A is row equivalent matrix C. What is the meaning of it? Meaning is that we can use only row transformation. The echelon or canonical form of matrix A is row equivalent matrix C of rank R with the following properties. So first, at least one element in each of the first R rows is non-zero, and the elements in the remaining rows are 0. And second, in the first R rows, the first non-zero element in each row is 1, and it appears in the column right to the first non-zero element of the preceding row. So what is the actually meaning of it? Very simple. You can see here the example of echelon form. A equal to 1 4 7 2, second row 0 0 1 6, third row 0 0 0 1, then 0 0 0 0, and last row is 0 0 0 0. So is it a echelon or canonical form of matrix? Definitely. So what is the rank? It is a 3. So you can see here in the first 3 rows at least one non-zero element, and remaining rows contains all 0 elements. That is the first condition. Is it? And the second condition is that in the first R rows, means here first 3 rows, the first non-zero element in each row is 1. So you can see here 1. First non-zero element of second row is 1. First non-zero element of the third row is 1. And it appears in the column right to the first non-zero element of the preceding row, means previous row. For example, for R2, you see which is a preceding row, that is a R1. In the R1, one present in the first column, means for R2, first non-zero element should present in the column right to the first non-zero element of the preceding row. It means that in the column 2, 3, 4, right side of this C1, 2, 3, 4, maybe possibility here, here or here. So here we got, here is 1. So in the R3, what is the possibility? Only one possibility, that is in the fourth column. So I can consider one more example here. You can see. Suppose rank is again a 3. Rank of this matrix. So definitely first, second and third row containing at least one non-zero and remaining rows containing all zeros. Supposed to be there like this. And first row, in the first 3 rows, at least one non-zero element, and it is first non-zero element is 1. So suppose here 0 and here 1. So first non-zero element is here, maybe here 2, 0, whatever there. In the second, now in the second row, it is compulsory, it is necessary, it should present, here it is present first non-zero element in the column 2, means necessary to present in. So here it is present. So here may be 3. So in the third row, so if you see the previous for the third is R2. In the second row, first non-zero element present in the third column, means only one chance there, that is in the last column it present, and it is 1. So this is a echelon form. How to find? Definitely we will solve some example on it, but here you remember these things. So let's consider one example to find the rank of matrix by echelon form. So here is that example. So how to solve? First, given matrix, you consider as A. So A equal to first row there 2, 3, minus 1, minus 1. Second row 1, minus 1, minus 2, minus 4. Third row 3, 1, 3, minus 2. And the fourth row 6, 3, 0, minus 7. So what are the steps to find rank of matrix by echelon form? So here we want 1, means at A11 position we want 1 by using only row transformation, because in echelon form we can use only row transformation. So here we want 1, then below that all zeros at a time by using this row and row transformation. So let's see how. So we can operate here R12, means interchange first and second row. So equivalence matrix is 1, minus 1, minus 2, minus 4. Second row 2, 3, minus 1, minus 1. Third row as it is 3, 1, 3, minus 2. And fourth row also as it is 6, 3, 0, minus 7. Now below that one we want zeros at a time by using row transformation. So that is why operate R2 minus 2R1 using first row, R3 minus 3R1 using first row, and R4 minus 6R1. So below that one we want all zeros by using row transformation and first row only. So I am getting here 1, minus 1, minus 2, minus 4. First row as it is. Now second row. So do this operation in the corresponding elements. So 2 minus 2, I am getting 0. So here 0, then 3 minus 2 into minus 1 means plus 2, I am getting here 5. Next minus 1 plus 4, it is 3. Then minus 1 plus 8, it is 7. Then 0, 3 minus 3, 0. So 1 plus 3, it is a 4. Then 3 plus 6, it is 9. Then minus 2 plus 12, it is the 10. 6 minus 3, it is 6 minus 6, R4 minus 6 R1. 6 minus 6, it is a 0. Then 3 plus 6, it is 9. Then 0 plus 12, 12, and minus 7 plus 24. So I am getting here minus 7 plus 24. So here the number is 17. Now at diagonal position, see here, diagonal position we want 1 by using a row transformation, but don't use first row. Operate R2 minus R3. So that is why I am getting here first row as it is 1 minus 1 minus 2 minus 4. Second row 0 minus 0. See there, R2 minus R3. Here 5 minus 4. Here 3 minus 9 and 7 minus 10. So what we get here? 0. Then 5 minus 4, it is 1. 3 minus 9, it is minus 6. 7 minus 10 minus 3. Remaining rows as it is. So 0, 4, 9 and 10. Last 0, 9, 12 and 17. Now by using this recent one and row transformation, obtain below that one zeros at a time. So operate R3 minus 4 R2 and R4 minus 9 R2. So I am getting corresponding elements. So 1 minus 1 minus 2 minus 4 means first row as it is, second row also as it is, and a minus 3. And third row now change 0, 4 minus 4 0. Now 9 plus 24. So I am getting here 33. Then 10 plus 12, it is a 22. Now last row 0, 9 minus 9 0, 12 plus minus minus plus 9 into 6, it is a 54. So I am getting here 66. So finally 17 plus 9 into 3, it is a 27. So I am getting here 4, 44. Next step is at diagonal position we want 1. Only by using only row transformation, do not use first two rows. And below that 1 we want zeros. Note that here, when here getting 0, 1, here getting 1, here I want 1 definitely, and next target is below that 1 we want 0. But here instead of this one, if any number, supposed to be here 33, and there are the multiples of this number, for example x, then here is 3x, here 2x, here 5x, like that, then without obtaining this here 1, you can obtain here zeros, and in the last step you just obtain here 1 by dividing x. So how? See here. So here 33, I want definitely here 1, and after that below that 1 zeros. But you can see 33 and 66, they are multiple, and that is why without obtaining 1 I can obtain their 0. So that is why operate R4 minus 2 times R3. So I am using this step only for the simplification, means simple calculations. Otherwise I have to use here divide by 33, divide by 33, and it will be difficult for the further calculation. So to avoid such difficult steps, I am doing this thing. So how? So I am getting now first row as it is 1 minus 1 minus 2 minus 4, second row as it is 0 1 minus 6 minus 4 minus 3, then 0 0 33 22, and last row it changes now 0 0 66 minus 2 times 33 means 66. So 66 minus 66, I am getting 0, and here also 0. After that, diagonally I want 1, but you can see in this corner all 0, means this is last. But before to that, I will use just here this third row divide by 33. So I can obtain here 1. So operate R3 by 33. So I am getting 1 minus 1 minus 2 minus 4 0 1 minus 6 minus 3 0 0 1 and 2 by 3. Finally 0 0 0 and 0, which is echelon form of matrix A or of given matrix A. So what is the rank? So rank of A equal to total number of rows minus number of rows containing all zeros. So what is it? It is the rank of A equal to m minus n. So I will denote total number of rows as m and number of rows containing all zeros, that is n. So here total number of rows 4 and a number of rows containing all zeros 1. So what is the rank of A? So required answer, rank of A equal to 3, which is your final answer.